Hello and welcome to lecture 31 of chapter 19, a comprehensive introduction to statistics. We are at present now wrapping up the chapter and we are doing this part, practical applications of hypothesis testing in data science and business. So you did this part in previous lecture, hypothesis testing in data science. We also did this part, hypothesis testing in business analytics. Now, starting from here, hypothesis testing in e-commerce. Now here one example is our well-known example which we have discussed in much detail in some earlier lectures, that A/B testing for the website design. So suppose you have hired new UI designer and you want to change the complete design of your online retail portal, and you want to check if the design change improves user engagement. For user engagement, you can decide some metric like say CTR, click-through rate, or average session duration, or other some maybe number of conversions or whatever. Now, if you are a big retailer like maybe Walmart or AWS or that kind of, Amazon that is, or Flipkart, that kind of big online retailer, then the web design is very important thing. So you may not like to change it abruptly for all the customers. In fact, you will change it for only few select customers, and the rest of the customers will continue to use the old design unless some clear proof is obtained that yes, the user engagement is improved by the new design. And again, you will have to design hypothesis. So null hypothesis will say that user engagement remains the same with old UI and new UI, while the alternative hypothesis will say that user engagement significantly improves using the new UI design compared to the old UI design, right? So now the question is which hypothesis is correct. Then for that you can use two simple t-tests, and if it gives that the p-value or the t-statistic both are satisfactory, then in that case you will say that yes, alternative hypothesis is correct and the null hypothesis is rejected. So new design improves the engagement. Similarly, personalized recommendation. So for the online portals like Amazon or Flipkart, whenever you click on say mouse, you have seen that your others the sections of the screen, they start showing different recommendation for that product. Not only that, they have the past history of your purchase behavior. So if they know that this person normally doesn't mind spending money for high-end models, but he prefers to only buy highly ranked, that is that 5-star or that kind of rating from hundreds of customers, that kind of product, and branded product only. So then the recommendations would be branded for those kind of product only. But suppose you are a low budget customer and you stick to medium price or low price products in your past purchases, then accordingly recommendation would be like that only. Now these are called personalized recommendations, right? But who knows if this personalized recommendation improve the sales or not, because for that you have to provide an entire recommendation system, and designing a recommendation system for a large online retailer is a really complex task, and therefore designing and then maintaining it, okay, so these are complex tasks, and you have to pay high salary to the data scientists and the data engineers and all that. Now if it is not improving the conversion rate at all, then why would you spend that money, right? So again, here null hypothesis is that the conversion rate without recommendation system and conversion rate after putting recommendation system both are same, while the alternative hypothesis is that after giving personalized recommendations, the conversion rate improves significantly compared to the case where no personalized recommendations were given. So again, it is a hypothesis which you have designed null and alternative, so you have to test. And for that, we can use chi-square test to study the impact of personalized versus generic recommendation. Generic recommendations are just that if he has clicked on mouse, then show him all mouses. But personalized is what I told, that based on your past purchase behavior, they can show you only custom type of mouses, right? So that is what is personalized recommendations and role of hypothesis testing in that. And actually, now in real e-retailers, it has been found that personalized recommendation greatly improves. In fact, Amazon has done several studies, and it found that around 15% of the increase in the sales revenue can be attributed to its better recommendation engine. Okay, so that is the situation. Logistic optimization. To test if a new delivery partner reduces the delivery time. Again, logistic is very important for most e-tailers, right? Because nowadays nobody wants to wait. So you should be surprised that how these people are able to cater to the need of thousands and thousands of customers, which if often goes into millions on the day of that Diwali sales or Republic Day sale or Black Friday sale, etc. Millions of customers are given delivery, and still a very precise time is given to you that you will receive your package on this day and between these hours and these hours, and you will be surprised, but they have around 95 to 99% of the accuracy that the packages are delivered in that time only. And that last mile of delivery is the most difficult thing to tame in e-tailing. Okay, so you have to choose your logistic partner carefully. Now, suppose your earlier logistic partner was 95% accurate delivery wise, but now you want to try another one who is claiming that I would be 99% accurate. So again, you will do design a hypothesis test. Null hypothesis will say that the delivery times with old partner and new partner are same. Alternative will say that with new partner the delivery time reduces by maybe say half a day per customer. Now that is a big saving in the delivery time, right? So then you can conduct a paired t-test, and if paired t-test gives p-value sufficiently smaller so as to give you confidence, that reject null hypothesis, which says that delivery time with new and old delivery partner remains the same. But you are rejecting that if your p-value is very small, and then you can switch to the new delivery partner. Product recommendations. Then if you are recommending product using collaborative filtering, then does it increase the average basket size? Okay, now this collaborative filtering is also one type of this recommendation system only, that it has several different ways of designing. There are several different ways of designing a recommendation system. One is this collaborative filtering, in which a common example is that when you click on some item, then below that item it is shown that people who bought also bought this. So that means that that recommendation is created by collaborative study of the features and the purchase history of those customers who had the same traits as you. Okay, so does it increase the market average basket size? Or sometimes that other thing, like people who bought this also bought these 2-3 items which are, say, with keyboard, they will suggest a mouse and a keypad, and maybe some other things also like that. With a mobile, they will also sell mobile cover and maybe the maybe a charger also, like that, right? So that kind of recommendation, does it increase the average basket size? Because if the people go for it, then their purchase bill will clearly increase. One person only buys mobile and another person buys mobile plus charger plus the cover and many other things, so his bill will be bigger. Now question is, are there significant number of customers who buy more after they are given that kind of suggestions? Then null hypothesis will say that collaborating filtering does not affect the market basket size, while this alternative hypothesis will say that after collaborating filtering is applied on the portal, the market basket size increases significantly. So you will test and compare the market basket size for users who are exposed to the recommendation versus those who are not exposed to that. Now these are two independent samples, so you can use independent sample t-test, or you can even use z-test also, like that. Okay. Now here there are some advanced use cases of hypothesis testing. Advanced in the sense that the collection of data and the analysis of data is difficult. Otherwise, hypothesis testing is hypothesis testing. You make null hypothesis, you make alternative hypothesis, and then you decide by using a suitable testing method that which of the two is correct. But advanced, because this is a time series example. So you testing whether a policy change, for example, tax cut, impacts monthly sales using pre and post policy data. Now this is particularly important on the some policy declaration dates, like for example budget day. Now in the budget day, suppose the government is likely to hike the tax rebate for the housing loan. So you have to test as a financial institution that before the budget day, when the housing loan interest rebate limit was, say, 1,50,000 rupees, and after the budget day, where suppose it is increased to 2,50,000 rupees, then does the loan application and the sanctioned loan increased by certain amount? Okay. Another example I can give is that on the budget day, suppose the government decides to put additional 20% tax on tobacco products. So a cigarette making company would like to analyze that before the budget day, when the tax was less on the cigarettes, and after the budget day, when the tax has suddenly increased by 20-25%, like that, then is the sales of the cigarettes affected? So now here it requires a streaming type of data, because you require it is a time series data, that on this date, this date of this month, this much was sold, and on this date and this month this much was sold. Then comes that precise borderline date, that is the day of the budget policy announcement, and then after that again you have to collect the data. Now that means you have to focus on various segments of your time series, right? And then perform hypothesis test on the mean of those segments. Mean segments you have to find. So that is why this is difficult. Health analytics is difficult because of a different reason. There is no streaming data or anything. Most of the time the data is simple, but the problem with health analytics is that accuracy required is very high in your hypothesis testing, or that means say normal 95% confidence interval or alpha is equal to 0.05 for significance level. That is not enough for healthcare domain. So we require 99% confidence interval, or alpha is 0.01. So if p-value comes out to be less than 0.01, then only you will reject your null hypothesis. For example, a new drug is launched which claims that it reduces cholesterol level compared to placebo by a significant amount, and you are the drug regulatory authority who is supposed to give the uh, approval, or you are supposed to deny the approval. So you will ask the test results, or you will conduct the test yourself, that divide patients into two parts. All patients are with high cholesterol level, but divide them into two parts. One group of patients will receive that new drug, of course voluntarily and after taking their consent, and another group of patients will receive a placebo, and then compare the two samples. Now why two samples here? Because these are two different, completely independent samples, right? It is not the same sample after giving drug and before giving drug that you are comparing, but you are dividing your high cholesterol patients into two parts, and one part is given the medicine, another part is not given the medicine. Now null hypothesis will be that the new drug has no effect on cholesterol level, while alternative hypothesis is that new drug significantly reduces the cholesterol level compared to placebo. So if p-value is found to be less than 0.01, then in that case you will accept the alternative hypothesis and you will say that yes, new drug is effective. Financial analysis, again this financial analysis is difficult because of the nature of the data, because one is it is streaming data. For example, you are making an algo trading platform, okay, so your algo trading algorithm, how it is working. Now stock market data is highly fluctuating and highly changing streaming data, right? So that is one problem with it, that it is difficult to handle. Other problem is there also, just like healthcare, that accuracy desired would be high, because sometimes if you are big financial advisor, maybe like JP Morgan or some that kind of thing, then you are handling billions and billions of dollars of assets. Then just a 2% of error, additional error, that will lead to the loss of millions of dollars, right? So then here also you can use confidence interval, maybe 0.98, 0.99, like that. And second is you will have to design your hypothesis and you will have to make your algorithm such that it can handle streaming data properly. So example will be, if you want to try a new trading algorithm produces higher average returns or not, then compare the daily returns using a paired t-test. So today you try that new algorithm, and on same stocks you try old algorithm also, then tomorrow, day after tomorrow, maybe for next 50 to 100 days, you try both algorithms on the same stocks, and then you compare them using the paired t-test. And if a null hypothesis is rejected, then you can say that yes, new trading platform produces significantly higher average returns, right? Now manufacturing quality control, so that is also one advanced use, because this predictive manufacturing that requires sensors and the data coming from sensors, you have to, that is IoT like devices, that they will send the data from, you have to analyze the data coming from sensors, and you have to predict that this machine part is going to fail, or here some in the manufacturing, if you are building say iron blocks, then this after every 200 blocks maybe there is going to be one defective block, or like that. So if you are predictive manufacturing new technology you are planning to introduce, and suppose it is a big manufacturing firm like maybe Larsen, or say some foreign firm like maybe Boeing or Airbus, but they will not accept your claim that my technology reduces the product defects. They will just test your technology on a small sample first, and again null hypothesis will be that the product defect rate remains the same with old and new technology, and alternative hypothesis is that product defect rate significantly reduces with new technology compared to old technology. Now in here you can conduct a two-tailed Z test and on defect rates, right, and decide which hypothesis is correct. Now this is one more thing, that whenever you conduct a hypothesis test, visualization is important, because visualization helps in interpretation. For example, if you find that correlation test, that just tells that whether or not two features are correlated, or whether or not one feature is correlated with the response variable. But again, whether it is positively correlated or negatively correlated. So for that you can plot a scatter plot and things become immediately clear. Similarly, for that gym diet example, one particular diet, three diets we had discussed. One was low carb diet, another was vegan diet, and another was Mediterranean diet. And we found that the diets have significantly different effects. And then we added one more parameter on male and female gender clients, and it was found that gender also affects the result significantly with a given diet. So I am giving that both examples. Just we have to scroll back so that you feel satisfied. Those who forgot that actually we have done that, right? So this is that correlation thing, and we found that suppose final yield is correlated with this. But again, whether it is positive or negatively correlated, that you can find by one scatter plot. Then now here you can see that number of eggs run on x-axis and the monthly sales on y-axis, and the trend is roughly like this. So you will say that yes, as more eggs are run, monthly sales tends to increase. Okay. Similarly, that weight loss examples with different diets that we had discussed, this case was there. Low carb diet, vegan diet, and Mediterranean diet, and green is for male gender and orange is for female gender. And we saw that each diet has different effect. And not only that, even for same diet, the effect on males and effect on females is different. By the median weight loss for male was 4.5, median weight loss for female was around 4.2, like that with low carb. So visualization helps in interpretation. That is what we want to discuss here in very brief, because actually we have discussed all these things in much detail in all those examples. So hypothesis test outputs. Now for output, you have to just specify one test statistic. So if it is a t test, then t statistic. If it is a z test, then z score and other things. If it is some other type of test, then sometimes f statistic is decided. For chi-square test, the chi-square value can be given like that. And second is always p-value, because test statistic is fine, but from test statistic, finally conclusion we don't draw. Okay, we just draw the conclusion always from the p-value. So from t statistic also we find p-value, from f statistic also p-value, from z score also we find p-value. We always find p-value, and if it p-value is less than alpha, significance level, then we can say that we can reject null hypothesis. If p is greater than alpha, then we say that we fail to reject null hypothesis. Similarly, so these two must be specified in your result when you specify your result, the test statistic and the p-value. Confidence interval also you have to specify that whether you conducted your test with alpha is equal to 0.05, then you should write that we are 95% confident that true mean weight of product lies between 490 and 510 grams. But if you conducted with alpha is equal to 0.01, that is 99% confidence interval, then you can say that we are 99% confident that the true mean weight of product lies in between this 490 gram and 510 gram. I gave the example also of that paracetamol or some antibiotic tablet, because in medical science you require higher confidence. So at that time 500 gram paracetamol is there, or 500 gram antibiotic is milligram, of course not gram, milligram antibiotic is there, then it should be maybe 499 on the lower side or 501 on the higher side, but more than that variation is not allowed, right? Now visualizing the result. Then we saw that bar chart can help, scatter plot can help, and box plot can help in visualizing. So when you report your hypothesis test results, you should at least not forget to report test statistic, p-value, what confidence interval you used, some visualizations to support your finding, and this is how you will write in a scientific manner how hypothesis test results should be reported as a professional data scientist. So when reporting results of a hypothesis test, follow these steps. Clearly state the hypothesis, H0 and HA. Describe the test conducted and why it was chosen. So what was your null hypothesis? What was your alternative hypothesis? Why you chose a particular test, and how? What is the basic logic of that test? In very brief, you don't have to describe it as if you are writing a statistic answer paper in the university, but still what that test gives in very brief, and why you chose that test only. Then present these results, test statistic, p-value, then confidence interval, then finally present your finding that you said you are taking these two as a hypothesis. So if the results were sufficient to reject the null hypothesis or not, okay. And last, relate the result to actionable insights, because okay, you go on speaking in this terminology, but the business owner would be interested in that thing, that please tell me what I have to do. So you can tell that yes, your new marketing strategy is going to work, and it might give you on an average around maybe 10% sales boost. So you go with that. That is called an actionable insight. Okay, that the end user can directly take an action on it, and he will get the tangible or visible benefit within just a small time interval. Okay, so this is an example of some scientifically written hypothesis test. That the result of two-sample t-test showed that the new model's mean accuracy. So suppose this is that test, we are assigned a job that instead of logistic regression for classification, now I want to use XGBoost for classification. But my data scientist has prepared this XGBoost model, but I want to do a third-party evaluation. So you are my consultant, and you evaluate that does his XGBoost model give higher accuracy compared to the old logistic regression model? Okay, so then that is the question which the business owner came with, and he sought your advice. Now you gave this kind of result, that the result of two sample t-test showed that new model's mean accuracy, that is XGBoost mean accuracy, was significantly higher than the baseline model's mean accuracy, that is the logistic regression's mean accuracy. And you will also say this kind of thing, that what parameters you obtain, right? So what are the t statistics and everything. So for that, here I think this one. Okay, so you are giving the, where is it? Yes, that the value t value was this much, and p value was 0.02, and that means that p value is less than 0.05. So confidence interval used was 95%. Now this 5% improvement in accuracy, because with logistic regression you are getting 85%, with XGBoost you are getting 90%, suggests that deploying new model could improve predictions and reduce false negatives in critical cases. Then if you had taken some liberty with the basic assumptions of central limit theorem, then you should acknowledge that liberty, that actually central limit theorem says that the sample size should be greater than 30, but this study was conducted to a small sample size, because as a data scientist you don't have to be ashamed about that, right? Whatever the client has given to you, you are creating, you are performing your analysis based on that sample size, right? So study was limited to small sample size, and therefore before taking big business decisions like switching completely to from XGBoost from your baseline model logistic regression, some more future work should be done to validate findings with a larger data set. Now this kind of balanced approach in reporting is required, right? And here still that confidence interval is not mentioned, so I am adding that also, that here was significantly higher as confirmed with 95% confidence interval. So that also should be specified clearly, so that if the company has millions of dollars at stake, then they may want to do the same test with 99% confidence interval, like that. Okay. Now this is real life examples. One we have already done, that we want to test whether a new scheduling system reduces patient wait time. Then this also we have done, I think, that if offering free, no, this we have not done. We had done discount. Now instead of that, this is also kind of discount only. That an online retailer like Amazon or Flipkart who wants to know that if as an extra incentive we offer free purchase, then does it change the customer behavior? That means do the customer have more chance of conversion, that is giving an order? Or maybe if they are all order giving customers only, but if you offer free shipping, that saves there around 50 rupees or so per item. So then does that increase average order value? Okay. So again, null hypothesis would be that with free shipping or without free shipping, the average order value remains same, AOV. But alternative hypothesis would be that AOV with free shipping would be significantly greater compared to AOV with without free shipping. Okay, and you can use two sample t-test. Now all this discussion, one confusion might remain in the mind of learners, that sometimes one sample t-test, sometimes two sample t-test. As such, that confusion should not remain if you have learned the lectures properly, because we have done 8 tests, then we have done 8 lectures, each of around 40 minutes or so. And in one lecture, we took only one test, so that the concepts are not mixed up. But suppose still you are confused, then there are some clear guidelines, or there is a good diagram also, a kind of decision tree like diagram, which helps you to decide which statistical test should be used based on given use case. Now, for example, let us see if there is something. Yeah, okay, there is something more also. So this choosing the right hypothesis testing, that we will do in the next lecture. Okay, so whether to use t-test or one tail t-test, one sample t-test or two sample t-test or chi-square test, what is applicable in which type of use case, so that we will take in next lecture. Thank you.